Hey everyone, thanks for joining us for our presentation today. We are Stagehand. My name is Cody, and along with Daniel and Emil, we're happy to show our project with you today. So Stagehand makes getting to production as painless as possible. Stagehand is a drop-in solution that provides review apps for modern front-end applications, and we'll explain everything we mean by that as we go along. General overview of what we'll be talking about today. We'll look at what review apps are, as well as their value, some existing solutions for review apps. We'll look at Stagehand and where it fits in and how we built it, along with some challenges we faced along the way and some future work we hope to get to. Before we dive into what review apps actually are, let's look real quick at where they generally fit in within the various environments of a production application. So any code changes to an application, like with adding a new feature, occur in a development environment, like on a dev's local machine. And then once those are complete, the changes are moved to a testing environment usually, which is optimized for testing specific requirements. And then prior to going live, the changes are typically moved to a staging environment, which is supposed to match the production environment as closely as possible for any final checks. And then finally, the code is pushed to the production environment itself to go live. Review apps generally fall under the same category as staging environments, which we'll look into now. So what are staging environments? Tommy McClung says that a staging environment, sometimes also called a pre-production environment, is the environment where your code is staged prior to being run in front of users so that you can ensure that it works as designed. A staging environment can be used for automated end-to-end testing, quality assurance teams, and even for product managers and other stakeholders to be able to validate that new features and functionality work as they're supposed to. So let's look at an example of this. Let's say it's your developer working on a front-end application. The product manager wants a responsive navigation bar added to the application, and you're assigned this task. After coding up and testing your new navbar feature, you deploy the changes to a staging environment. And here the product manager and other stakeholders can view your changes in this production-like environment. They can play around with the new feature, like your navbar, making sure that it's what they want and that everything works properly. And then once approved, your new navbar feature can go live into production. But what if you're part of a dev team that's assigned a wide variety of features? So now you, Alice, and Bob are all working on different parts of the front-end app at the same time. You're working on the navigation bar while Bob works on the page content and Alice works on the footer. All of these features will have to be deployed to a shared staging environment where your changes can be verified by the product manager and other stakeholders before they can go to production. But because this environment is shared between all of the devs, maybe you and Alice will have to wait until Bob's done using it. And furthermore, you and Alice may have to clean up that staging environment or make some changes to your own code if there are now conflicts with Bob's code after he's finished. This type of bottleneck is in the development cycle is one of the many scenarios in which review apps are incredibly helpful. So what actually are review apps? Review apps are ephemeral, fully functional versions of a production application that can be easily deployed and shared with others. By ephemeral, we mean that review apps are temporary environments that can be automatically torn down at any time. Fully functional means that review apps have end-to-end production-like functionality. Easily deployed means that review apps can be instantly built and deployed whenever there is a change in the application's code. And then review apps are self-contained in that they exist in isolation from the main production application. So let's revisit our dev team. With review apps, each developer now has their own isolated environment where they can easily deploy and share their new feature. Now you and your team no longer have to fight over that shared staging environment just to be able to do something as simple as deploy and share your new features for others to check out. Each review app can be accessed even by non-technical stakeholders via a unique URL that you can share with them. This also enables greater collaboration even within your dev team itself, as you can now quickly show each other your work without having to pull down and run each other's code locally. So no more fighting over that shared staging environment just to quickly deploy, test, and share your new features as they're being developed. So let's zoom in and see what review apps actually look like in action. So here on the left, you have opened a pull request for your new navigation bar feature on the GitHub repository. This triggers a review app to be automatically built and deployed, and a shareable URL to be posted. So now you can easily check out your work yourself, as well as share it with others, like the product manager is seen here, or the rest of your team. So the product manager wants you to move the navigation bar to the other side of the page. When you make this change with a new commit to the pull request, a whole new review app with this change is automatically deployed with a new URL. And this new review app exists at the exact same time as the previous review app, allowing them both to be viewed at the same time and even compared side by side. So you share this new version with the product manager, who, after comparing the two versions in the review app side by side, is now happy with your latest change. And now you can merge your new feature code with the main application where it can be promoted to production. And then after your code is merged and your pull request is closed, both of these review apps will be automatically torn down for you as they're no longer needed, freeing up resources. So why front-end review apps? Review apps are an incredibly helpful tool for developers of all types of applications, but their benefits are particularly helpful for developers of front-end applications. Why is this? So first, because front-end apps deal heavily with end-user experience, more visual testing and verification in a deployed environment is needed. Second, review apps are more lightweight, so they don't need to spin up as much infrastructure and resources as a full stack app. Third, because front-end apps are decoupled from data level concerns, front-end review apps mimic the final production environment much more closely than a full stack application. And then finally, because the functionality of review apps are more user or consumer facing, there may be need for more sharing of new features and functionality with non-technical stakeholders. So review apps fit all of these front-end applications needs extremely well. So now let's look at what exactly we mean when we say front-end applications. In order to understand what we mean by front-end applications, it'll be helpful to contrast it with a full-stack web app. So here we have a conventional 3-tier web app architecture. First, a request comes in from the client. And then second, all of the assets for our app are built once that request is received. Third, the response is then served back to the client in the form of HTML, CSS, and JavaScript. So the key thing to remember here is that the assets for our app are built at the time the request actually comes in from the user. With a front-end application, things work in the opposite direction. First, when a change is made to the code or content of the app, that's when all the assets for it are actually generated. And then those pre-built assets are pushed to a content delivery network, or CDN, for hosting. So when a user makes a request, they are instantly served the latest pre-built assets for the CDN. So when we say that Stagehand is for front-end applications, we mean that it's applications that can be pre-built and instantly served from a CDN like this. And we also support a more dynamic type of front-end application. So here's a front-end application that works just like the one in the previous slide. In step one there at the top, the pre-built assets for our front-end application are instantly served to the client from a CDN. But some front-end applications, like single-page applications and Jamstack applications, have some more complex client-side JavaScript that gets served back. This means that after the client receives the response from the CDN, data can then be fetched from the client from an external API via that client-side code. So this allows modern front-end applications built like this to have more dynamic functionality similar to a full-stack app. Stagehand also supports review apps for this dynamic type of front-end application. Now let's look at some existing solutions that provide review apps for developers. There are generally two types of review app solutions. One is reviews as a feature, and the other reviews as a service. Reviews as a feature offers review app functionality as part of a larger hosting service like Netlify, Vercel, and Heroku. And then reviews as a service exists only for managing and hosting your review apps. And examples include FeaturePeek, Release, and Tugboat. Let's look at some trade-offs with these two types of review app solutions. Neither of these are fully open source, so you don't actually control the infrastructure or code used to manage your review apps. Both are convenient options as they automate review apps for you. And because Reviews as a Service specializes in review apps, it's typically a more flexible solution for a multitude of needs, and you're not tied to a larger hosting service like Netlify. Both solutions host your review apps for you, and both are feature-rich right out of the box. But what if we don't want a hosted solution? What if we want the extensibility and control of an open source solution? One option is to do it yourself. To manually develop a solution for deploying and managing your review apps yourself in a self-hosted way, you'll have to provision and configure a rather large number of resources. So you'll need a cloud storage solution to store all the assets for each of your review apps. You'll have to provision and configure a CDN service for hosting. You'll need to write and deploy serverless functions for processing needs such as routing. And then you'll need to provision and configure a build server to automate the building, deploying, and tearing down of your review apps, as well as any interaction with your code repository on GitHub. And then finally, you'll need some services to secure your review apps according to your needs. So let's revisit the trade-offs table and include the do-it-yourself approach. Do-it-yourself gives us all the benefits of open source, but it can now, as we last saw, be very labor and resource intensive to set up and a bit of a headache. It's flexible as we're not tied to a larger service, and we can now self-host our own review apps ourselves, but we don't have a lot of features out of the box, so we'll have to develop any that we want ourselves. But what if there was a non-hosted open source framework that doesn't require all the work of the do-it-yourself approach? This is where Stagehand fits in. Stagehand gives you the same trade-offs as the do-it-yourself approach, but we automate this whole process for you. Stagehand is fully open source. We conveniently automate all the infrastructure you need for your review apps. We're flexible in that we're not tied to a larger hosting service. We allow you to self-host all your review apps on your own infrastructure. And like the do-it-yourself approach, we're not feature-rich right out of the box. So now let's dive in and see how Stagehand works and how we built it. And Daniel's going to walk us through that.
Thank you, Cody. So Stagehand gives you review apps for any front-end application that could be pre-built and served from a CDN. So we're including frameworks such as React, Gatsby, Hugo, Next, and so on. Once Stagehand is installed, you only need one command to set up your repository with it. After you push your code to GitHub, each pull request and any additional commit you make will automatically create a review app for you. It's that simple. We'll show you what it looks like in action after your repository is already set up. So first, a pull request on the Stagehand demo branch is created. This will trigger a review app to be created, and a shareable URL will be posted to the comment section. This review app has the Stagehand dashboard logo on top, and it's open with the Stagehand logo in the top left-hand corner. It will display a banner giving some context information about the review app and reminding you that you're not looking at the production environment. After a commit is made off-screen on the same branch, this will trigger yet another review app to be created, reflecting those new changes. A new URL is posted, and now you can have multiple review apps to share and compare. So Stagehand is made up of 3 parts with a command line interface to pull it all together. We combine AWS Cloud Infrastructure, GitHub Actions, and client-side code. While this is a lot to throw at you all at once, we're going to keep this pretty high level right now, and then focus on each piece as we progress through the presentation. So first, we'll show you how Stagehand deploys review apps on AWS Cloud Services. Then we'll walk you through how Stagehand automates the deployment and management of the review apps with GitHub Actions. And finally, we'll go through some client-side code we use to handle routing and to create a dashboard for users' review apps. So the first piece we'll go over is AWS components. We pick AWS due to its popularity, especially among individual developers. So there's two flows of our AWS components. If you look on the left, when a user makes a request to retrieve a review app asset, and if you look at the top, when a review app is being created or torn down. We're going to zoom into each of these pieces and walk you through what they are in more detail next. So the S3 bucket is our storage solution. You could think of it as a database for files. This is where we store each of the review apps in its entirety. And to distinguish review apps from one another, we use the current branch name and the current commit identifier as its path. CloudFront is our CDN or hosting solution. So all HTTP requests coming into our infrastructure will first hit CloudFront, which will forward it to the S3 bucket to retrieve the correct asset. CloudFront also handles securing requests to the bucket and provides us with an out-of-the-box domain to use. The last infrastructure piece to add is identity and access management, or IAM. This enables us to tightly secure the access to CloudFront and S3 bucket. It also ensures that the credentials can't access anything else in the AWS account where all this infrastructure is located. The last step is how to deploy our AWS infrastructure. So we use CloudFormation to take care of this. It allows us to use a template with listed resources, configurations, and outputs, and it'll spin up all the infrastructure we need. And we didn't need to customize each AWS stack to each Stagehand app, so a template was a perfect approach. We could then use the outputs to automate aspects of setup later for a smoother user experience. Another bonus of having all your resources grouped together is not only that you can spin it up easy, but you can also tear it down easily. So we've seen how AWS helps us serve the review apps. Now let's look at how those review apps are managed with GitHub Actions. So we're going to talk about why we use GitHub Actions and what it exactly is. And then we'll walk you through one of our workflows. And to understand why GitHub Actions exists, let's talk about a very common scenario for a GitHub user. You want to build your Gatsby application every time a commit to your code base is made. And for those who don't know what Gatsby is, all you really need to know is that it's a framework to build front-end applications. So to make this happen, what would you have to do? The repository itself can't run code. We need some place for the Gatsby build to be executed. We can solve this by having a server somewhere, which will receive a notification from GitHub letting us know when to start the build process. Then we'd have to pull down the code from the repository onto the server and then run the build command. GitHub noticed that this was an incredibly common flow of events that people would do. So they wanted to devise a way for you to run code directly within your repository, eliminating the need to spin up or configure your own server. So this is what inspired GitHub Actions. You now have a way to run code within the context of your repository. So GitHub provides each repository with its own server so that you could run code on it in response to GitHub events. And if you recall, the events we're concerned about, pull requests and commits, are repository level events. So GitHub Actions is perfect for our use case. We can leverage the server GitHub provides to build our review apps. As a user of Stagehand, you don't even need to be aware of what GitHub Actions are or how to use them. We handle setting it up entirely for you. So now that we know the use case for GitHub Actions, there's one final piece to explain. How does our repository know that we want to run an application build on every commit? The workflow file is the only piece of information we need to provide GitHub. In this file, we'll have all the configuration and the logic of running the application build. These workflow files must be located within your GitHub repository, and a single repository can have many workflow files. So we're going to shift back to the context of Stagehand, walking through what GitHub Actions does when a pull request occurs on a Stagehand app. So starting off the process, first a pull request is created in your repository. This creates a pull request event. GitHub will see that the create review app workflow file inside your repository is listening to when pull requests open. This will trigger the workflow to begin. GitHub will then read the workflow file and provision a server for you set up with all the appropriate environment credentials. The final step is where all the meat of the logic happens. The GitHub server will execute the contents of the create review app workflow, and this in turn will build the review app, copy that build to the S3 bucket, and publish a comment containing the URL of the review app. And that's all. Aside from the create review app workflow, we also have one for teardown. So now we have a better understanding of how GitHub Actions manages the review apps. Let's take a look at the client next. So in this section, we'll explore how Stagehand client uses an iframe to give us a dashboard and uses a service worker to handle routing. After that, we'll take a walkthrough of how we get from the dashboard to the review app. So there's two fundamental pieces to our client-side code: the Stagehand HTML file, which includes an iframe, and the JavaScript file, which installs a service worker. While you may not be familiar with either of these two pieces yet, we're going to walk through what each of them provides for us. So the Stagehand HTML file provides a scaffolding of a dashboard. The Stagehand dashboard visually sits on top of the review app to give extra context to the viewer of the review app and reminding them that they're looking at a review app and not production. While the information that our dashboard gives at the moment is a banner, this setup allows the user of Stagehand to easily build out a custom dashboard to do and say whatever they want. How do we get this overlay on the review app though? We use an iframe. And the iframe represents a nested browsing context, embedding another HTML page into the current one. So you could just think of it as a web page within a web page. It's just a simple HTML tag. So if you look at the image on the right, while we separate the main window from the iframe visually here, you can style the iframe so that it can be indistinguishable from the main window. So next, we'll dive into what a service worker is and how we can use it to handle routing. So we could have an entire presentation about the power of a service worker. So we're going to try to contain the scope of what's important for you to know to understand how we're using them. So they essentially act as a proxy server that sits between the web application, the browser, and the network. So a service worker is a browser feature. It is not infrastructure. It is code that runs inside your browser. And once it's registered to a domain, it intercepts all the requests going in and out of that domain. And the service worker is able to alter both the request and the response. So in our case, we're going to intercept the HTTP requests. There's two important takeaways here. Thinking of them as an in-browser proxy, and they are able to send and receive messages from the browser. But before we start walking through what the client request cycle looks like, we're going to visit the GitHub server. So on top of adding the review app to the correct location in the S3 bucket, we're also adding the appropriate Stagehand client files with them at the same time. So each review app will have its own version of the Stagehand client files. And now the browser is ready to fetch the Stagehand HTML file. The HTML file will provide the scaffolding for the dashboard and the review app. It will render both the dashboard and the iframe that will later house the review app. And to populate the iframe, we need to first grab the service worker and the JavaScript file that will register the service worker. And here we receive the JavaScript file and then the service worker file, and the service worker will begin installation. Remember, a service worker is code run in the browser, not cloud infrastructure, and it intercepts events coming in and out of the browser. So after the service worker is installed, all HTTP requests coming out of the iframe will be intercepted by the service worker. The service worker will make sure it has the correct path to the correct review app and then forward the request to CloudFront. This gives us a one-size-fits-all approach to managing the routing. And this occurs for not only HTML pages, but all other assets like CSS and JavaScript. The service worker will then forward the response to the iframe, so the review app will be populated with all the assets it needs. Now that we've walked you through all the pieces that make up our architecture, we can take another look at what this all looks like together. So GitHub Actions automates the management of the review apps. AWS handles storing, securing, and retrieving the assets, and the client handles the dashboard and routing. Emil will take over and walk you through how Stagehand CLI is used next.
Thank you, Daniel. So now that we understand how Stagehand is built, we can discuss how it works from a user perspective. We provide a straightforward CLI tool to the user to manage their Stagehand apps. It's a node npm package, so setup is just one command in the CLI, npm install-g stagehand-framework. So the init command forms the meat of our command line tool. You use it by navigating to the root directory of a project you want to use Stagehand on, and then when you run the command, a list of easy-to-use prompts are provided. App configuration details are obtained, then various local files are added, such as the .github directory, which is provided to all GitHub projects, and that is populated with our GitHub Actions workflows. A .stagehand directory is also created or updated in the user's home directory, and it holds persistent information about the local stagehand apps the user has access to. This command also runs the AWS CloudFormation template to provision all necessary AWS infrastructure. The process also automatically adds required secrets to the user's repo via the GitHub API. So all in all, this process makes setting up review apps as simple as running this command and waiting for the process to finish before continuing with the normal developer workflow like commits and pull requests. The list command is used to list all stagehand apps you have access to. So once these are displayed, you can select a single app and view all available review apps. Then as the GIF shows, you can select a single review app from the terminal to automatically open in the browser. This allows you to interact with the review apps without having to navigate to github.com and look at the pull requests. The add and access command work together to alter and view access control. They allow collaboration between users on different devices who want to use the same stagehand app. The destroy command is the opposite of the init command. It's run in the root of an existing stagehand application. It removes all related local files such as the workflow files in the .github directory. It also removes references to this app inside the .stagehand directory, so this app won't show up when running other commands like stagehand list. And last but definitely not least, this command tears down the AWS infrastructure. So now we know how stagehand was created and how it can be used, we'll delve into some of the specific technical challenges involved in its creation. Remember that our final architecture used a service worker on the client-side code to handle routing, and a iframe was used to add a dashboard as well. While this is our final approach, our original solution looked quite a bit different. We'll be covering this original solution in our upcoming section. In order to understand the routing problem, a certain amount of historical context is needed. So let's just say you're a Google engineer and you've been given the task to create a Maps app. When the app is coded up and then its assets are built, it has no awareness of where it's going to be hosted or what its domain will be. Because of this, the app is coded using relative paths, which are shown above, like routes, /settings, etc. So what are relative paths? Relative paths assume the domain to be used is the same as the current domain. Therefore, relative paths only specify how to get to the new asset relative to the current file's location. So if you're hosting the Maps app at google.com, all of its assets will be relative to that domain. Thus, /routes, which is a route link, will navigate to google.com/routes. Because relative paths are used when navigating within an app, this means the application code is unaware that it's actually hosted at google.com. However, there's already an app being served from google.com, so we can't use that. So we want to serve our entire Maps app from the /maps path. Unfortunately, the application code will not be aware of this change, and it will look for the set asset in the wrong place, as you can see in the image. This results in a 404 across all relative assets. Instead of going to a google.com/maps/routes, we're going to google.com/routes. How do we ensure that all of our requests from the Maps app goes to the correct location? Well, a traditional way to handle it is that a web server will take all requests coming from google.com and figure out which application to forward it to. This way, only the web server needs to know which path belongs to which app. So now that all of our application requests are going to the correct location as shown above, but how do we solve this if you don't have a web server? For example, what if all of our assets are hosted on a CDN, content delivery network? We need a way to intercept the request response cycle and make sure it's going to the correct place. So there are two ways we can solve this. There's the infrastructure interception solution, which involves adding serverless functions to our CDN, or there's a browser interception solution, which uses a service worker on our client-side code. So to understand how all of this relative routing stuff relates to stagehand, let's recall that each review app had a branch name and a commit identifier. So these two pieces are referred to as the base path. The base path in the S3 bucket corresponds to the start of the URL path in the browser. Each of the review apps for a single stagehand app are hosted at a unique base path under the same CloudFront URL. So if you look at the browser image on the left, you can see one CloudFront URL, 1245.cloudfront.net, which corresponds to a single stagehand app. On the bottom right, you can see different base paths, which correspond to different review apps within that single domain, right? That single CloudFront URL. This is similar to our Google Maps example earlier, where we wanted multiple apps hosted under google.com within different paths. So why does this all matter for stagehand specifically? The major problem we then need to handle in stagehand is how do we add a base path to our site so relative links work within a review app that is nested under a specific base path. What we expect to happen is on the top right, we expect the relative link, so clicking /about, to take us to test/12512/about, right? So that's, you expect the relative link to automatically add the base path after the domain and before the relative path is clicked. However, we don't have a web server that can automatically intercept every request to CloudFront and manipulate it to add the base path. So what actually occurs is on the image at the bottom right, the relative path is added to the domain without a base path, and an 404 occurs because that item doesn't exist. So in order to solve this, we initially used the infrastructure interception solution. So our infrastructure introduced Lambda at edge functions to intercept the requests coming in to ensure that the relative paths were going to the correct location. AWS's Lambda functions are serverless functions used to run code without having to provision a full server like an AWS EC2 instance. They're event-based and their code will execute in response to a trigger. This means we can run code in response to certain CloudFront events such as an incoming request and a request to the S3 bucket. The next slide will go into more detail about how we use Lambdas for processing. Here we have Lambdas that trigger for both a CloudFront request and an S3 bucket request. That will enable us to do any extra processing that is needed to ensure the requests are all routed to the correct asset. So note that this is our first solution, not the final architecture. Unfortunately, we found this solution to be incredibly limiting. It required more user configuration, a lot of build time changes, and also limited the number of frameworks we could support with the solution. Because of this, we went with a browser interception solution that used service workers. All right, so let's quickly review Stagehand's actual solution. So initially, Stagehand HTML is requested, and that returns a dashboard and the iframe, which will later contain the review app. Then a service worker is requested and installed. Thus, any requests from the iframe for the review app will be intercepted by the service worker to ensure the base path is always added as the image shows. Here, we're handling routing on the client side without having any additional infrastructure involved. So now that we've solved the relative routing issue with client-side code, there's another issue that comes up. What happens once a relative link is clicked? Well, the iframe content will update, so that's good. But the URL in the main page will not change. That's because it's not the content that's changing, it's the iframe URL that's actually changing. Unfortunately, the user can only see the main window URL. So we need to update the main window so that it matches the page that the review app is on. So note that in order to make this update, we're going to need to use URL fragments as shown on the right. Otherwise, the main window, when its URL changes, will automatically make a new HTTP request. So our first attempts to fix this was to use the post message API and the broadcast channel API. Both of these APIs were tricky to get the messages to the right client, especially when we had multiple review apps, and they also had some cross-browser support issues. So as a result, we needed another solution. We decided to have the main window continuously pull the iframe to see if the path had been updated. If the path had been updated, we update the main window accordingly. So this basically used the iframe location as a source of truth. So now that we covered some technical challenges involved with creation of Stagehand, let's reiterate what exactly Stagehand does for its users. So we started off our journey by showing you what review apps are and the value they can bring to a development team. And we ended up giving you the power to turn your own front-end application into the best production it can be. So allowing you to self-host review apps without worrying about a thing. Before we wrap up, we have a couple of things on the horizon we'd like to add to Stagehand. So we'd like to develop dashboard templates for specific use cases. We'd also like to implement our solution across non-AWS cloud providers. And we'd like to provide an option for using a self-hosted GitHub runner, so a unique VPS like an EC2 instance instead of using GitHub's default servers. And last but definitely not least, we'd like to create an automated test suite. Thank you for watching. And this is us. If you have any questions now, please let us know in the chat or the Q&A.
All right, so here's a question from Gabe in the chat. He says, what did you guys find to be the most difficult aspect of this project? I would say probably handling that relative paths issue. It seems like when you get your head around it, it's a pretty simple problem. Like all we need to do is add in that base path, right? But when we don't have a web server like we went through, it was it was really challenging to figure that out. So getting to the service worker solution as a general one size fits all was really challenging. So I would say that.
So we got another question from Ezra. What's the cost of running Stagehand on AWS? That's obviously going to vary depending on the size of the application and how many review apps you have open. For us, we did an enormous amount of testing on this, and I'm pretty sure our bill didn't even exceed a couple cents. But you definitely haven't got any emails either. So as long as your app doesn't have thousands of review apps, you should probably be fine cost-wise.
We have another question from Oscar Romero. So I had a question regarding access. So if a pull request or review request create a link, can anybody open the link that Stagehand created, or only the initiator of the pull/review see it through GitHub and any other valid GitHub login work? So anybody can view these links. Because these are front-end applications, we didn't see, like, we're not dealing with any production data. So it wasn't too high of a concern to kind of protect people from seeing the links.
Here's one from Arthur. He says, what's the most interesting thing you learned while doing this project? I think it's different from all of us. Like, I think it was just interesting to learn the technologies we use, to learn about, you know, the different AWS services and to pick which ones were best for a use case. GitHub Actions is a brand new thing that's incredibly helpful. And then, yeah, and then service workers is a whole world into itself where we didn't even scratch the surface of the power there. So I would just say all the technologies we learn.
Yeah, I think after discovering about service workers and like looking into it, I kind of fell in love with them. So I definitely want to look a lot more into them, about the different aspects that we didn't quite get into in this presentation and in our project.
So Gabe had a question of how long does the initial deployment of Stagehand and AWS take from the init command to being able to click on a link and see the app? So regarding the running the init command, the primary, I guess, blocker, if you want to call it, would be setting up the AWS infrastructure, specifically the CloudFront CDN. So some of that is going to depend on AWS's efficiency, but generally like a few minutes in some cases, and sometimes it might take a little bit longer. Now, regarding creating a review app, again, that's going to depend on how long the build takes. So if you have like thousands of files to build, obviously that'll take a lot longer. And if you're using a framework that's known to be slow versus a framework that's known to be fast, is also going to play into it. Again, for smaller apps like the ones we demoed, we're talking minutes usually, as long as nothing goes wrong. Yeah.
Here's one from Rodney. He says, can you briefly go into more detail about the process of setting up the CLI portion and what you had to consider? So the CLI, because the whole process starts on the user's local repo, we want to automate as much of the process as possible from right there. So that meant getting their AWS credentials, being able to sync and not have to have the user manually go in and add the plethora of GitHub secrets that they're going to need for their review apps. So it was just automating that whole process, finding the balance between what's too much to ask from a user and how much we can automate for them. We ended up automating quite a bit. And we also made the decision not to go, at least right now, with like a huge graphical like dashboard to look at review apps, because you're working in the context of pull requests on GitHub, you already have that graphical interface there, so that the CLI can just handle any of that on the client side for you.
So to kind of add on to that, the only things we really needed from like a Stagehand user to know how to spin up their Stagehand app was the commands that you use to build your application. And then we also needed to know how the certain framework that you're using builds its assets. So there's some like little quirks that some frameworks have. So we just kind of separated into like 2 different categories of routing. So Gabe says, what was your guys' experience of working with AWS? Did y'all find it easy? Were you able to pick it up quickly? The AWS infrastructure that we kind of finished off with was probably the easiest part of the AWS that we used. We went over kind of briefly how our first iteration used Lambdas, and Lambdas are probably the hardest thing to work with and to debug. So after we gave up, or we found a different solution that didn't use Lambdas, it was a lot more straightforward. I don't know if Cody or Emil has anything to add to that.
Yeah, regarding the AWS infrastructure, that definitely checks out with me. Also, like once I figured out how to use the documentation a little bit better, so like initially it was a little bit tough since I had to figure out where things were, but once I figured that out, in the general structure of how AWS likes to do things, it was easier to pick stuff up.
Yeah, same. It's AWS is really well documented and powerful. It's, I think the most challenging part was figuring out what services of AWS to use for our use case. But once we did, it was really easy to learn and pick up. Rodney asks, how long did it take to build? Oh, wait, you got this, Daniel. Go ahead.
Oh, so I think the majority of the time we kind of spent on this whole process was in researching the project. It took us a while to find what exactly we wanted to do. We were kind of puttering around different kind of like front end framework tools. So we were looking at static site generators, and we were looking at Jamstack applications. But in terms of once we actually like sat down, we knew what we were doing, and we started to build it, probably took like, I don't know, like 4 weeks, something like that, 3-4 weeks.
Yeah, the prototype came pretty fast, but getting everything really polished up and working and expanding, you know, what all types of front end applications that we support took a little time after that.
So it looks like, as I was asking, is Stagehand available on GitHub? Yes, it is, and sooner write-up will be as well, which I'm sure we can share in Slack or something once it's ready.
Yeah, and the NPM package is ready to go as well if you want to try it out on your own repositories.
Yeah. It's called Stagehand-Framework.
So Aram asked, maybe I missed it, but what else could service worker be used for? So you didn't miss it. We didn't really want to like go into the weeds of what service workers could be used for because they're kind of a confusing concept. But the thing that they're used primarily for is something called progressive web application. So basically, I don't remember there's like a list of 6 or 7 different things that like a lot of progressive web applications have as like traits. But one of like the most important things that it can be used offline. So it uses a couple different browser APIs, like a cache and a database. So if you're offline, let's say you're working on something like Google Docs, and your Google Docs goes offline, all the changes that you're typing in aren't going anywhere to the Google database, but instead they're just getting saved in the browser. And then once you go online, that all that information that was saved in the browser by the service worker will then be sent to the Google database to update the Google Sheets. We just have one final question from Edmund Tam. They're asking, would it be possible to extend this to backend instead of just front end? So a couple of the different services that we went over a lot earlier in the presentation, release apps was one of them, and they do like a full stack review app. It would kind of be hard to adjust Stagehand to that at the moment. It would involve like a lot more work. which is why we kind of contain the scope of just using front-end applications.
And also it's harder with full stack applications if it's reliant on like a lot of data for review apps to mimic a production environment with a full stack app versus a front end application.
Yeah, I'll just add related to that. If you want to like try this out for a full stack, I think Heroku has something similar called Heroku Review Apps. And I know in the core you use Heroku, I believe for 170. So you could try something like that.
Here's one from Rodney. Can you tell us about how it was working as a team and what you would say is something each of you would consider and how your experience was? So I guess that's for all of us. It was a lot of fun working with these guys. I think I think we worked really well together. It's when you're on a team and you're remote and sometimes your schedules don't sync up, like that can be a challenge at first, but I think we overcame all that and we were able to really put in the work and collaborate well.
Yeah, it was great working with these two. It's nice that, because I think everybody goes into the process with their own strengths and weaknesses. So it's nice that you have a balance of that. So it's sometimes when you're kind of like lacking in one department, somebody else picks up the slack, which is always nice to have. What I would recommend, like going into Capstone, is communicate like a lot, like over communicate everything just to make sure everybody's on the same page. And like during this whole process, take lots of notes.
So Justin asks, what happens to links generated when a pull request is submitted but never merged to main? So if you leave the pull request just open, the link will just remain there and the review apps will remain up. Now, if you so when you merge a pull request in to main or you close it, right, they both involve closing it. So, right, so the close event for a pull request is triggered, and that'll cause all the review apps in that, so all the links in that will basically go down, right? All the review apps related to that will be torn down by the workflow. So yeah, if you don't close it at all, then it'll just remain up.
Yeah, in which case you would have to use our CLI to actually manually get rid of those review apps if you want to do that while leaving the pull request open for whatever reason.
Thanks everybody for coming out and watching our presentation, and for all the great questions. And take care.
Thanks, guys.
Thanks.